David Smith here with another Flipped Classroom math video. A few tips before we get started. Remember, you can always pause the video to make extra notes or write down questions for when we meet in class. Also, remember to pause the video when I provide an example. Work that problem, then start the video up again and see how well you did. You can also turn on the captions so you can see my words written below on the screen. You can also speed up or slow down the video if you wish. Remember to think hard, follow along, and bring your best brain to the next time we have class. Today's topic, problem solving, also known as word problems, also known as story problems. In all my years of teaching math to high school students, I find that these types of problems are often the most challenging for students to even get started on, let alone solve. So I have a method, 5 steps, that generally will help you get through that. I want to urge you, when you read that word problem, if you don't know how to do it right away, don't give up. Start with step 1. Maybe you can do step 1. Then in the course of doing the first step, what to do in the second step might become clear, and so on. Before you know it, you might actually solve that problem. Or maybe you get 80% of the way through. In my class, that's a bucket load of partial credit. Okay? So calm yourself, have confidence in yourself, follow the steps, and you might just get all the way to the end. Okay, let's take a look at this. I'm going to go over the method, and then we're going to do some problems. The first step, read the problem carefully. I don't know how many times I've seen students do great math on the wrong problem. Make sure you understand what's being asked for. I think it's a good idea to jot down some notes or make a sketch or a diagram, particularly if the problem relates to geometry. Okay? Name your unknowns using variables. What is the unknown? Well, if at the end of the problem it says, what's Sam's age? Then write x equals Sam's age. That kind of thing. If at all possible, use only one variable. So if x is Sam's age and Bob is 5 years older than Sam, then Bob's age is x plus 5. Don't use a second variable for Bob. If you can express one unknown in terms of the other, that saves you a lot of grief. Now what you want to do is use your variable to write an equation. They're going to give you some information in that word problem that's going to let you do that. Keywords to look for are equals or is, because that sets up the relationship between two quantities that you can then solve. Okay? So once you've written your equation, go ahead and use your algebra or your geometry skills to solve that equation. Do your math, check your work, get to your answer, give it a nice circle. Finally, take a look at that solution. You can check it in 2 ways. The first way is it reasonable? Let's say we had Bob and Sam's age and we did a bunch of math and we got Sam is 460 years old. Well, that's probably not correct. So think about that. Sometimes people just miss that. It's not a reasonable answer. If it's a decent problem, the answer should be reasonable. Second thing, once you get to your solution, you can plug it back into your equation and see if you get the same result, if it works. So that's a more mathematical check. So if you follow these steps every time, you're going to make more progress. I can't guarantee that you'll get through every word problem, but over time and practice, you'll get further and further along. Okay, here's a sample problem. Let's read it. The sum of a number and its square is 42. Find the number. Now let's make sure I understand what's being asked for. Let's see. I've got this number, okay, sum of a number. Sum means I'm going to add this number to something else. Let's read again. And its square. Okay, the square of the number, what's that? Oh, that's when I square it. Like 4 squared is 16. Okay, I get that. So if I have this number and I add its square to that number, I'm going to get 42. And, oh, they want me to find the number. Okay, all right, I can do that. So now I want to name my unknowns. Okay, so I'm just going to go x equals the number. Bam. Okay, Second was to write an equation. Okay, so now I got to think, I got to turn this into math. So the sum of the number, let's see, I'm going to add, and I'm going to add the number, and I'm going to add the number to its square, the square of the number. How do I write that? Oh, that's x squared. And is, remember, that's equals, is 42. So let's check. The sum of a number and its square is 42. Yeah, I think that's good. So this is a unit on quadratics. To solve, I need to get one side equal to 0. So I'm just moving the 42 over. Now it's equal to 0. Now this quadratic is set up so that it's factorable with the product sum method. Maybe we'd have to do complete the square. Maybe we'd have to split the middle term. Sometimes it might be a GCF. Sometimes you might need the quadratic equation. Those are all techniques that we've been exploring in this chapter. But this one's a pretty straightforward one. I need two numbers that multiply to minus 42 but add to positive 1. And those are positive 7 and negative 6. So I'm going to go x plus 7 times x minus 6 equals 0. So again, the reason that comes up that way is 7 times negative 6 is negative 42, and 7 plus negative 6 is positive 1. Almost there. Let's finish solving. We know that this has to be x plus 7 equals 0, so I get x equals negative 7, and this one is x minus 6 equals 0, so I get x equals 6. So my solutions in set notation are negative 7 and 6. Okay. Is this reasonable? Kind of interesting. I wasn't expecting two numbers that would work for this, but maybe it's true. So let's take a look. Negative 7 squared is 49, plus negative 7 takes it back down to negative 42. So that one works. Let's try 6. 6 squared is 36, plus another 6 is 42. So many quadratic equations will have two equally valid solutions. Okay? So I think we're done. Okay, let's try a geometry problem. This one reads, a rectangle has length 5 centimeters greater than its width. If the area is 84 centimeters squared, find the rectangle's dimensions. Okay, so let's think about this one. It's a rectangle. Okay, I know what that is. Length, that's one of the sides. And width, so that would be the other. The length is 5 bigger. Okay, I get that. So if the area is 84, okay, so they're telling us the total area, find the dimensions. So that must mean they want us to know length and width. Okay, great. So this one, geometry, means diagram. So let's do that right over here. I'm just going to draw a rectangle. And now I can put some labels on that. Length is 5 greater than width. So I'm going to use x for my variable. And what I'm writing here is I'm showing that the length is 5 more than the width. So if the width is x, then the length is going to be 5 plus x. And there's something else I can add to my diagram. I like to do this. Just write a equals 84 cm squared, and this is cm. Okay? So now I have a diagram with a geometry problem that's super important that I can use to think about this problem. Okay, so I've read the problem. I've actually kind of done the first step. I could go x equals width, and x plus 5 equals length. Now this is important. A lot of people, when they encounter this problem, they're going to do x equals width and use some other variable, maybe y, to say length. It's reasonable, it's just hard to solve this with two different variables. So fortunately they linked them together. We know that length is 5 more than width, so we can write it this way. I have only one variable. Okay, now we need an equation. Well, here's a clue. They tell us what area is. We know that for a rectangle, area is length times width. So my equation is going to be x width times length equals 84. So I know my area is 84. I know how to get area. length times width. So this is a valid equation for that situation. Now we need to solve this. Let's do a little distributive property. X squared plus 5x equals 84. We're getting there. We need to set this side equal to 0, so we'll subtract our 84. X squared plus 5x minus 84 equals 0. Now I can solve this one by factoring. It's another product sum type factoring, pretty straightforward. Two numbers that multiply to 84 but add up to 5. Multiply to negative 84, add up to 5. I happen to know that 7 times 12 is 84. This needs to be positive, so my 12 is going to be positive, my 7 is going to be negative. So I would do x plus 12 times x minus 7 equals 84. So 7 times 12, negative 7 times 12, negative 84, that's right. 12 minus 7 still leaves 5. So that's a correct factorization. We'll finish up. X plus 12 equals 0. That gets us x equals minus 12. And here's x minus 7 equals 0. That gets us x equals 7. So there's my two solutions. Now think about that. There's something wrong. Did you figure it out yet? Okay, check this out. That's a rectangle. Have you ever heard of a rectangle having a side length that's negative? Can't do it. Distance is always positive because it's a real thing, distance. You can go in a positive or a negative direction on a number line, but you can't have negative distance. So this solution is not valid for this problem. It solves the equation. If you plug in negative 12, it's going to work, but there's no real world meaning of that. So this is not a solution. This one is our answer. So are we done? No, we're not done. What we did is we solved the quadratic equation. We found two solutions. We chucked out one, but we have a solution to this equation. The word problem was asking about rectangle dimensions. So the width is x. We found x. Width equals 7. Length is x plus 5. So length is 12. Now, these two problems in this video do not cover all the possible word problems that you could get. So there's a great many kind of geometry problems based on all the different geometry that's out there. There's lots of algebraic type word problems that come out of all kinds of different situations. So often the hardest step for a word problem is that first and second step. Can I understand what's being asked for? Can I write a variable? And then followed closely behind, can I write a valid equation? Once you have an equation, solving it is a lot more easy. It's a lot more about rote mathematics, which is just chugging away through steps, keeping it correct so you can solve. The critical thinking part is reading the problem, coming up with how to define variables, and writing a valid equation. And to be true, it just requires practice. So practice. If you still have questions, write them down now and bring them to our next class. You can also watch the video again and perfect your notes. Finally, if you enjoyed watching my video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.